Okay, these slides are about programming. Fire sensor. It detects the infrared light from a fire. We are using it has 4 pins: analog output, ground, VCC, and a digital output. We are only using the digital output, and VCC and ground are provided. Analog output is not used for this project. Okay, LEDs. Okay, LEDs have 2 pins, anode and cathode. How to tell which is which one is which one? So there are multiple ways to tell that. Here are a few. Either you can look at the length of the lead like that leg. So the longer one is the anode and smaller one is the cathode. Either you can look inside of the LED. The smaller section is connected to the anode and the larger section is connected to the cathode. Okay, this is the reference of the ESP32. We are using these pins with 3.3 volt, ground, GPIO 15 and GPIO 2. GPIO stands for general purpose input output. 3.3 volt, ground and GPIO 15 are connected to the fire sensor, while the GPIO 2 is connected to the red LED, which we are using to indicate. These are the connections. This is a 3.3 volt, which is connected to the plus via VCC. This is a ground, which is connected to the ground through here, and this is a GPIO 15 pin, which goes like this to the digital 0 pin, and here is the GPIO 2, which is connected to the anode of the LED. You can see the smaller part is connected to the positive terminal. Anode is connected to the ESP32, and the cathode is connected to the ground through a resistor, 220 ohm resistor. Okay, we will first interface the flame sensor and the LED. Start your Arduino IDE. These are two variables, sensor and LED, storing the pin number which they are connected to. Sensor is connected to pin 15 and the LED is connected to pin 2. Okay, so we have to set the pins input, whether they are input or output. So this is the function, pin mode function. The pin mode function tells the ESP32 that the following pin is input, either input or output. So you can see pin mode sensor input. So the sensor pin 15 is set as input, and the LED pin, which is the pin 2, is set as output. After setting the pins as input and output, we will use digital read and digital write functions to read and write from the pins. The sensor pin 0 T0 is connected to the pin 15, and our LED is connected to the pin 2, as we have defined over here. The digital read function will read the pin 15 sensor and store the read value, the output variable. The rated value can either be 0 or 1 based on the if flame sensor detects the flame or not. If we compare the output with 1, if it's 1, means the sensor, if output is 1, means it has detected the flame. So we'll write the LED high. This LED high will turn on, the LED will turn on. In other case, we will write the LED low. If it hasn't detected a flame, then we write the LED low. Okay, we can compile the code. We have written so far and tested. Here's a video. You can see that when the flames lit near the sensor, it turns on the LED and it turns off as soon as the flame is extinguished or removed. To tell the PC what is going on in the controller, we use a serial port communication. Here's a serial port terminal. You can click on it. The serial port will open. Here you can see there are different baud rates, communication rates we can use. It's most commonly used is 9600. Serial.begin function. Okay, we are using serial.begin. 9600 is a baud rate. This function starts the serial communication with the PC, and we can use it to send message to the PC and tell which process is going on in the controller. S is capital in the serial begin. There's mistake. We have called this function in this void setup because it just needs to be run once. We are going to use IFTTT if then that web service, online service. We have to make an account, so we can search on IFTTT. This is the website. You can click on start today, continue with Google, or you can make your own account. You can continue with Google, or you can make your account through email. I continue with Google. Okay, I'm using PCs, so neither, and can continue. You can select any one of this. I have selected the location or notification. It's below this one. Okay, free trial, I don't need it, so not now. Get started. They're recommending applets. We are making our own, so get started. Okay, to go to the create, in the next window you have to go to the create. This window will open, so you can see this is the condition. If this means this occurs, then do that, then do this. We can add our condition from this add button. We have to search the webhook. Webhook triggers. What it does, it receives the HTTP or JavaScript request. So we'll select the webhook. What kind of webhook we need? So we need a web request. So we receive a web request. We don't need the JSON file. Just need a simple HTTP. We'll connect. Okay, what trigger, name of the event, what event. So var detection is the name of the event, and create trigger. You can see it is added to the if then that. This is the condition, the trigger, and what it has to do. We have to send an email. So press add, search email, and email. Send an select this email action, HTTPS email. Emails have two things: body, subject, and body. So here you can write the subject, here you can write the body. So subject was fire alert, and from body we need the time when occurred at. So we'll remove the other extra date and what we'll just leave this line and we'll write our own. So fire was detected, take action, and line from when occurred, time and date, create action. And you can see it is added. Send an email. If we receive the trigger, then he'll send an email. Continue. This is a review. You have to confirm. Okay, now you can see it's connected. You can go to the webhook service. From here you can click here. This page will open. You can go to the documentation. documentation you can see it shows your key and how you can receive the web request. So we have not selected the JSON file, we have selected the web request. So here's our HTTP address to get the web request. So this will be used in the code, and this is our key. You can see it also includes the key. Okay, now we're connecting to the ESP32 to Wi-Fi. We have to include the Wi-Fi library in the ESP32 Wi-Fi.h, and then we need the SSID and password of the password of the Wi-Fi. SSID is the name of the Wi-Fi, like you can see, and Gogo is the SSID of my Wi-Fi. Okay, we have stored the SSID and password in constant char. Constant char tell that its value cannot be changed, and char it's a character, it's the name of the variable, and star indicates that it's a pointer. Wi-Fi.h is the header file included for the Wi-Fi, and SSID and password are added to the variables. Just like the serial, we have the Wi-Fi begin function. Wi-Fi begin function connects to the Wi-Fi. So Wi-Fi begin function needs SSID and password of the Wi-Fi which it has to connect. So you can see in white setup we have called Wi-Fi begin SSID and password. Okay, as we know that Wi-Fi connecting to Wi-Fi takes time, so we must wait before doing anything else. So you can see after Wi-Fi begin function we have called the while loop. The while loop with a delay. What this will do is it will wait until the Wi-Fi is connected. So what is it doing? Wi-Fi checks the Wi-Fi status. If it is not connected, it will give a delay, print a dot, and check again. So it will do so and so until it is connected. So if your Wi-Fi is not connecting and taking too long, you can either check the password or SSID you have provided might be wrong. And when the Wi-Fi is connected, it prints Wi-Fi is connected.